Okay, so we are on to the very last lesson for today. Again, has to do with trig. So this is for angles or triangles that don't have a right angle. So only ever use the trig ratios, whether it's primary or secondary, if it's a right angle triangle. Um, but you're gonna get some that aren't. And this is where you're gonna use this. I will give you guys a flow chart to help you out with this once I find the file for it, because I spent a lot of time making the flow chart quite a few years back. So this one's called Sine Law, and this is used when you, hold on here. This is used when you have two side lengths. Okay, so I'm gonna write side notes. So not right angle triangle. Try, oh my goodness gracious. Okay. Apparently I forgot how to write there for a second. Triangle. And this is when you have two side lengths. And one angle. Okay, we're gonna see tomorrow, there's one if you have three side lengths or if you have three angles, but this is used when you have two side lengths and two angles. So the sine law, when you have an angle, you would use this one. So sine of A over A equals sine of B over B. Okay, so your A is your angle, your smaller a is your side length. When you're trying to find a side length, it's the same thing, it's just it's flipped. Okay, so it's A over sine A equals B over sine B. Okay, so I'm going to show you some examples. There's three of them for you there, and then you're on your own and you have the rest of the day to yourself. So I'm clearing this. Okay, so far we have done calculations using right angle triangles. For these, we use SOHCAHTOA. Today we solved for acute triangles using the sine law. So like I said, it's not a right angle triangle and you only have either two angles and one side or two sides and one angle. So we're gonna look at the example here. So we're looking for this side length here. So we're gonna name this A, and this is the smaller A. This is large B and this is small b. So the side lengths are across from the angles and they're named the same letter. So we're looking for A, so that means that we're going to start off, we're going to use this version of the equation. Okay, and we're going to substitute our A because we know it's 55, our small b with 9.2, and our big B with 90. Okay, so this is X. This is sine of 55. This is 9.2. And this would be 90. Okay, so we want to solve for X. So right now it's being divided by sine of 60 or sine of 55. So we're going to multiply by sine of 55 on both sides. So it cancels that out and we get our X on its own. So this is 9.2 sine of 55 over sine of 90. Okay, and you can use this for right angle triangles. It's just there's no point when it's a lot easier with trig ratios. So that's why there is a 90 there, but yeah. Okay, so 9.2 times sine of 55 gives us 7.5, and sine of 90 is 1. So our side length there is 7.5 centimeters. So this is the answer for this guy. Wow, that was an awful arrow. Okay, so we're going to look at example 2, and that is actually our last example. So I'm clearing this. Okay, so find the interior angles of the triangle to the nearest degree. So here we don't have a single angle. So you're sitting there probably like, well, miss, I thought I needed at least one angle. How can I do this? So here is where it gets to started. So if this is 124, this whole line here is going to be 180. So we want to try finding out what this small one is. So this small one is going to be 180 minus 124. So that little angle there is 56. So you don't even need to use the sine law for that. That helped you out right there. Okay, now we want to find another angle. So what we're going to do is we're going to try finding this angle. So we're going to label this one A and smaller a. This one will be B and the smaller b. Okay, so because we're looking for an angle, we're going to use this version of our sine law. It does make it a lot easier if you swap it like that. It doesn't really matter. It's not going to give you the wrong answer. It's just easier to solve for the angle. Okay, so sine of A, we don't know A, but we do know the side length for it is 112. Sine of B is 56. And then over 98. So again, what we're going to do is we're going to multiply both sides by this lower term. So it cancels it out. So sine of A is equal to 112 times sine of 65 or 56 over 98. If you punch that into the calculator, it's going to give us 0.9474. But we need to get rid of the sine. We don't just have our angle. So we're going to do the inverse. Okay, so hopefully at this point you know how to do that in your calculator. So our angle there is 71 degrees. So this is 71 degrees. However, we need to know all the angles. There's an S there, that means all of them. So this one is going to be quite easy again because all angles inside of a triangle add up to 180. So we're going to do 180, subtract our 71, and subtract our 56. And it's going to give us that angle. And so that's 53 degrees. Okay. What I do ask of you for this is that you do draw it, or you do make it clear to me when you're writing what's what. This can get pretty messy when you're looking for all side lengths and all angles. So hopefully you guys are organized enough to make it easy for me. If not, then it's not the end of the world. And that is it for our Monday.